So sharing the OneNote. So is visible to all OneNote.
Yes, sir.
Yes, sir.
Okay, fine. So in the last lecture we have started the Cauchy's mean value theorem. So actually Cauchy's mean value theorem is what? It is based, there is a two function, and the two function is for the parametric expression. Because some we know that we writing the curve function of x function of finance. Similarly, the one other representation of curve is parametric equations. So the Cauchy's equation is based on parametric equation of the curve. Okay. So I given the problem, simply just you have to extract the what is the fx and gx, and from there you calculate and put the values and make it RHS and LHS equal to RHS something. Okay. Hmm. So I'm dealing something with again, which is mean value theorem, geometric, still joining geometric, meaning of Cauchy's mean value theorem. Okay. Hmm. Suppose means that curve gamma is described by a parametric equation. Suppose means we is let let gamma be a curve represented by the parametric equation is x is equal to function of t and y is equal to function of gt. Okay. We can also write like okay, no issue, x is equal to t and y is equal to yt. Define and define on the closed interval AB. And by the Cauchy's theorem, same thing we written. So it is function is continuous and differentiable. Okay. So by Cauchy's theorem, what we can write this one, y of the two intervals, y of b minus y of a upon At the same point, we are taking the interval a and b. This is the means values of t is there, and this is x of b minus x of a. Actually, I have written y not x. F, F, and this is G and G. We know that this is representing the average change of the function f over the intervals, and it which is just is equal to the instantaneous change of the function at point some c. Okay, so we writing here f dash of c upon g dash of c. Or this term already we know, we can write the things here f of v f a upon like b minus n gb minus g upon b minus n. F dash of c and g dash of c. So this is the when you make a graph. Okay, graph is so this is here the point. This is a. So means t is equal to a here. So we have f a comma here, and here the point f of b comma and g of b. Okay, so we are drawing the straight line here. Okay, one more bit, we can draw the line.
एयरपोर्ट पे नहीं हो रहा, बाहर जाके मेट्रो स्टेशन पे होगा। दिल्ली एयरपोर्ट से अगर आप आ रहे हो तो मेट्रो स्टेशन दिल्ली एयरपोर्ट के टर्मिनल।
Okay, so this point, this is what? This is the line is code. Okay, so we can find a point C. I'm telling about the geometrical. So f dash of C, this is the point here. It's C. We cannot solve this in C actually. Rajendra Prasad, mute yourself. Hmm. So we take here tangents. We are drawing a tangent. So which is parallel to this one. Okay, we try to draw a tangent. So here we are getting this one tangent. Aksara Reddy, mute yourself. So this is the point. So here we have f of c comma g of c. So what is the slope of this tangent at this point? Okay, you know that in the parametric equation of a curve, what is the tangent? Anybody? What do you write at this point? Slope of this tangent at this point C.
G dash C upon F dash C.
Yes, and then C upon G dash C. So this is the slope of tangent at x is equal to means t is equal to c. So this is the instant change of the curve, which is equal to the average change. So we can find this one like average change. Okay, so average change is what? So this one is the average change. This is the g of t, and this is the f of t. So this length is how much? This is the g of b minus g of a, and this length is f of b minus f of a. Okay, the slope of the line, this is suppose a and b. Okay, this is equal to line AB is equal to FB minus FA upon GB minus GA. Okay, and which are the lines two are parallel, so therefore FB minus FA and GB minus GA is equal to F dash of C and G dash of C. Okay, just a second. Okay, so I will ask you in, you tell me that for what value of f and g it's become the Lagrange's mean value theorems. Yes, anybody?
So if gx equal to c, g of x equal to x, if differentiation.
So when
G
g,
of x equal to x, then b minus a is.
yes, means when you take gb, means gb is not a fixed value. When you replace gx is equal to x, okay. So when gx is equal to x, obvious gb something is there. Okay, suppose b dash and ga is equal to a dash. Hmm. No, that's why it is. So this is if then the given Cauchy's mean value theorem reduced to Lagrange's mean value theorem. Okay, fine. So geometrical interpretation like the same as the Lagrange's mean value theorems. Okay, so one thing is different. Here is the parametric equations, and there is the function of x only, means equations. Now we come to the problem. Yesterday I given one problem. In that problem, you have to. Okay, we complete the problem because many of them may have some doubt to how to solve. Question was so that sine A sine B upon cos B cos A cot C. Okay, where A C something B is pi by 2 and greater than 0 solution. Okay, in the last lecture we have seen this one. We have to solve this one problem. So we have to extract what could be the fx. So fx is equal to, we know that fx minus fa minus fb upon fb. So fx is here now sine x, and Gx is what become cos 6. So f dash of x is equal to cos 6 and g dash of x is equal to sin x. Okay. Because their derivatives are important. So by Cauchy's theorem, because endpoints is both here, is A and B. Similarly, just apply the Cauchy's mean value theorem. Okay, before we apply, so we have to check since fx and the gx, what we have defined fx and gx are both continuous on closed interval AB and derivable. Derivable on open interval AB because sine and cos functions. Therefore, by the Cauchy's mean value theorem, by Cauchy's mean value theorem, what we have FB minus FA upon and GB minus GA is equal to F dash of C and G dash of C. Already C is defined in the given interval. Now put the values FB means this is the sin X. So you write here sin B minus sin A, and this is GB means cos B cos A. F dash of C, X and sin. F dash of C is cos C minus sin C. Now, due to these things, so either we have to change the numerator, we can change removing the minus sign, sin A sin B upon cos B cos A is equal to this is cot C. So you have to write the some steps. When we writing this expression, it must satisfy the condition of continuity and differentiability according as the Cauchy's mean value theorem. Next question. If fx is equal to 1 upon x squared and gx is equal to 1 upon x, then so that Cauchy's mean value theorem C is the harmonic mean between A and B. Solution. Okay. Hmm. So, how you show the harmonic mean? Is it possible? Okay, so I'm giving you 2 minutes time to check if this is harmonic or not, and tell me the relation between among the C, A, and B.
Yes, sir, it is the harmonic mean C equal to 2AB upon A plus.
And that is harmonic.
2AB upon A plus B, C equal to.
C is equal to
2AB upon A
2
plus
AB upon A plus
A plus B. Okay, so what is C is equal to AB upon AB? What this relation is called?
C is the harmonic mean of A and B between A and B.
Harmonic expressions. Okay, in the three terms A, B, C. Okay, fine. Hmm. So, like there are many problems. Okay, you can do this one, and now we can move for the Taylor's theorem. Okay, Taylor's extension theorem. Okay, we're coming to that. One more problem we will do. So you have to go through the process. You have to just first write the statement continuous in the given interval, and actually it is written that so that Cauchy's mean value theorem. That means it satisfies the condition, and after that you are taking the values A, B, and C. So you will have the that relation, that is C is equal to 2AB upon A plus B. Okay, so you have to do this one complete. This is answer. Okay, one more question you can try. Let's see be a curve define parametrically as x is equal to a cos cube theta, comma y is equal to a sine cube theta, theta less than equal pi by 2 and greater than equal to 0. Question is there, determine a point P on C. Okay, C that means C1 is the name of the curve. Okay, P on C where the tangent to C is parallel to the chord joining the points a comma 0 and 0 comma a. Okay, this is important questions. So here let's see be a curve defined on parametrically. Okay, please like written parametrically as x is equal to a cos cube theta and y is equal to sin cube theta. Theta is lies between 0 to. Now point P, a point we have to determine is point on C. C is the curve is here, name of the curve. C is not that point, but we have to determine that point where the tangent to C, where the tangent to C is parallel to the chord joining. Means same definition we are using, and the here this is the in point A0 and 0A means f of a comma g of 0 and f of 0 comma f of a like that. Okay. So you just use that the Cauchy's mean value theorems and fine, you will have the some equations. After that you can you will get the some point values of x and y something. That is the required point.
A by 2 root 2 comma a by 2 root 2.
Yes, sir.
Yes, sir.
What?
A by 2 root 2
A by
comma
2 root 2, comma A by 2 root.
This is the answer is a upon 2 root 2 comma, and this is uh, this is your answer. Okay, required point. Hmm. Okay. So we have finished all our mean value theorem. Okay. So in mean value theorem, so far we studied the Rolle's theorem, and second one the Lagrange's mean value theorem, and third is the Cauchy's mean value theorem. Okay, so these are telling about the average change of the function, which is equal to the state change of the function at a given point. Okay, one more thing, so it's establish the relation between the function and its first order derivatives. Okay, so we already solved the one related expressions using the mean value theorem, Lagrange's mean value theorem, have we seen? Okay. So now, now we are going to study the more general form of this mean value theorem. That is called the general mean value theorem in the higher.
Excuse me, sir.
Yes.
Sir, can you please confirm the value of theta for which the answer was given? Was it pi by 4?
For this one answer.
Yes, sir. The previous one.
Wait. This problem.
Yes, sir.
So a upon 2 root 2 and a
Yeah,
upon
that
2 root.
that's coming. But I was asking that can you please confirm the value of theta? Like the value for theta, which the answer is coming is pi by 4. So is it correct or not? Like that is what I'm asking.
Theta is equal to pi by 4.
Yes, sir.
Theta is equal to pi by 4.
Okay, thank you, sir.
Okay. So because when you are solving, so it's you have to transform into sine cos in one variable because this value is cos cube theta and sine theta. So tan theta is 1 and theta is equal to pi by 4. And after that, you have to put this value theta in x and y so that you will have the answer.
Yes, sir.
Okay, fine. So we were talking on the more general form in the higher orders. Okay. So that is the Taylor's expansion. I think you have done something. Taylor's expansion means to say we are going to approximate the functions by polynomials. Okay, like you know the series. So e to the power x is equal to sorry one plus x upon factorial 1 x square by x cube upon factorial 3 dot. So this is in series, infinite series. Okay. So what we are doing here, this function is approximated by this polynomials. Okay. This. Okay. Means when we take 2.5. Okay. So it is some delta 1 value and 1 plus 2.5 upon factorial 1 plus 2.5 factorial 2, 2.5. This is square here, cube. And suppose we restricted here, we calculated, we have delta 2. So what happened? Delta 1 approximately equal to delta 2. So that means we are for a given value means exponential for x is equal to 2.5 approximating by these polynomials. Okay. So when you subtract delta 1 minus delta 2 means exact value, this is the exact value and this is the what approximate value. So delta 2 minus delta 1 is equal to, you will get error. Okay, it is also known as the remainder term. Okay, so expansion, you have know the things. So here we are going to know about the Taylor's theorem or Taylor's expansion with Lagrange's form of remainder. So Lagrange's form of remainder, the Lagrange's has the approximated the error by the given one term. That term may be is added in the Taylor's expansions. Okay, because we cannot move for the infinity case. Okay, the convergence and divergence, that is the other things in the sequential series. Okay, we are talking about the this expansion. So now I'm going to write the definition, Taylor's expansion theorem. Generalized mean value theorem and higher order. Okay, so we are studying now Taylor's theorem with Lagrange's form of remainder. So how we can define? Simply we take the function fx of function. Let fx be defined and have continuous derivatives up to n plus 1 nth order, one order in some interval I. Okay. So this interval containing a point A. Okay, let fx be defined and have a continuous derivatives up to n plus 1th order in some interval I. I is not defined, but I will ask you what could be the I. Containing a point A. Okay, I'm not writing here C, so don't confuse with the A. So A is here. Then Taylor's expansion of the function fx about the point x is equal to A is given by fx is equal to fa plus x minus a upon 1 factorial f dash of a plus x minus a square factorial to f double dash of a plus it's going on x minus 4 to the power n factorial n fn means nth derivatives plus one more term x minus this is n plus 1 n plus 1 factorial this is n plus 1 and there is the point c for this remainder. Okay, while stopping we are not going for it where c um, where rn. Okay, this rn is equal to power n plus 1 upon n plus 1 factorial f of n plus 1 c and c is less than hmm, c is less than x and greater than a. Is known as remainder or error term of the expansion. Okay, you see by this definition, Taylor's theorem with Lagrange's forms means here we are considering is what it should be derivatives means what we choose the function should be n plus 1 derivatives or n derivatives in some interval. The interval I just written I containing a point A, that interval containing a point A, then Taylor's expansion of the function fx about the point is given by. So here what we are going we have written the Taylor's expansion of a function at point means around the point x is equal to a. Okay, when we say that a function is continuously differentiable, that means it is also continuously differentiable at the neighborhood of the a. So this is your Taylor's expansion with the Lagrange's remainder. This Rn, which is called the remainder, extracted by this error with the Lagrange's. Similarly, there is the Taylor's theorem with the Cauchy's remainder. So, but that is not in your course. Okay, some other forms. So, how much it will be that error? It is you can extract by using these functions. Okay, when you are approximating any functions. So here C is the point which is lies between A and X. So can you see what could be the interval here? Interval is lower limit and upper limit. What could be the lower and upper limit? Anybody? Yes, am I audible to all? Yes, am I audible?
Yes, sir.
Yes, sir.
So can you say about the interval? Interval is here 0 or x is not 0. Wrong. It is A and X. And there is the C which is below X. Okay. Sometimes C may be written as C is equal to A plus theta x and theta is lies between greater than 0. Okay, sometimes. In the some books they are writing place of c is a plus theta x, but theta is that is approaching the because theta is what the fraction of one. Okay, so what could be take the lower limit or upper limit? See, when we taking here 2 comma 5, so when we write 2 comma theta 5, so what happens? Theta is less than 1 greater than 0. So what happens? So obvious this 2 is the lower limit and upper limit is what? Uh, so not the things here. We need to write plus comma is not 2 plus. So in given the interval 2 and 5, the values may be 2.5, 2.6, 3 and 4, 4.9 something. Okay. When we take 2 plus theta 5, where theta is less to fraction part, so fraction of 5 is something. So they are making just approaching to the 5. Okay. Another form we are going to write of this Taylor's expansion. Similarly, okay, the rest of the statements, rest of conditions are satisfied. Taylor's theorems we go to derive. Taylor's theorem for interval a comma b. There was previous ex. So what we do, we replace x by b. Okay, there is a two fixed value. Taylor's theorem for a b. So Taylor's theorem will be writing for the function fx. Okay, so x is here fb at the point b because int the lower limit and upper limit. So upper point we are taking. This is f of a, and the next difference is b minus a upon factorial 1 f dash of a b minus a whole square by factorial 2 double dash of a plus dot dot plus power n upon factorial n a and plus remainder term what we write a power n plus 1 n plus 1 factorial f of n plus 1 n plus z derivatives c, where c is lies between b and a. Okay, so in this case is what we see, the lower is a and upper is b. In the previous there is the lower is a and b is the x is the upper. Okay, so we are expanding the given function at the right hand, means upper limit in terms of lower limit. Okay, and we are using the length of intervals. Okay, in this case, we are finding the given function is related with the highest orders, their highest orders. One another form, when we write it, Taylor's theorem for interval, so a comma a plus h. Okay, h is very small. So what in this case? So we write the function at a plus h value. So lower limit is a, and this is a plus h minus a is h upon factorial and f dash of a plus h square factorial 2 f double dash of a plus dot dot h power n factorial a plus rn. The remainder term is to the power n plus 1 and factorial plus 1, f n plus 1, and we can write here a plus theta h. So theta is less than greater than 0. Means a plus theta is what is equal to c, where which is less than b and a. So means to write theta is less than 1, greater than 0. Okay, this is another form. When you take here a is equal to 0, so f of h is equal to, this is 0 and h upon factorial 1, f base of 0 comma h squared by factorial 2, 0, like that. It's moving on in the same manner. Power n factorial fn 0, remainder term also 1 n plus factorial and f of n plus 1, and there is the point c or something. So in this case a becomes 0, so you directly write here h. So h is what, less than 0. So this is all about the Taylor's theorem. Okay, Taylor's expansion with the Lagrange's form of remainder. Okay, so today is not possible to discuss the problem because time is over. Okay, I think you have another meeting. So tomorrow we'll discuss the problems which is based on the Taylor's expansion. As the application part, we are not going to write this proof of this theorem, how we writing this. So these proofs are written in the books, you can see, but you have to do the problems which is related to the application of Taylor's theorems. Okay, in the next class, we meet tomorrow. I think tomorrow is the time 10:30. Okay, we discuss the problems 10:30. So one more thing. So those who have attended the class, please mark your attendance within the time to 4 p.m. Any question? Any query?
Sir, please send the PPT of the class.
Yes, definitely. So I will send you this PPT of this class.
Okay, sir.
Okay.
Thank you, sir.
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 धन्यवाद.